All right, so what we're looking at now is section P4, which is factoring polynomials. And as we said in class, factoring polynomials means that we're breaking it apart into the product of smaller expressions. So we take one larger expression and we break it into smaller ones. So on your quiz, there was an example that looked something like this. These may not be the same numbers, I don't recall. But the idea is, in your quiz, you were multiplying them. And now what we want to do is take the end product, which in this case would be 12x squared 18 minus 22x plus 6. We would want to take this expression and go back to the product that yielded that expression. So why do we do this? Oftentimes we end up factoring quadratic expressions. Oftentimes we factor quadratic expressions which represent parabolas. Which, as we mentioned in class, could represent projectile motion. All right, and so we looked at that in that simulator just to get an idea of what it would look like. Now, when we first begin factoring, the very first thing we always look for is greatest common factors. Okay, so usually our teachers will always, call them the GCF. And so we want to always look and see if there is a greatest common factor or a GCF and take it out. So then the question becomes, well, what is the greatest common factor? What is a GCF? So when we're looking at just numbers, the GCF is the biggest number that divides both. And then when we start looking at our variables, as we mentioned, it's going to stem from the smallest exponent because that's going to be the most that they have in common. So for example, if we're looking at letter A here and we want to factor these using the GCF, the largest number that divides 5 and 15 is 5. The letters, we have an X, if we have 3 X's, and then another 2. The most that they have in common is 2, so the GCF is 5x squared. When I take out that 5x squared, that leaves me with 1x minus 3. So that if I were to distribute this 5x squared back in, I would end up with 5x to the third minus 15x squared. So this 5x squared times x minus 3 is the factored form. That's what we're looking for. All right, similar idea in B, except this time I have 2 terms. And what they have in common is this parentheses, x plus 1. So I'm going to factor out what they have in common, the x plus 1. And then I'm going to write down whatever it is that's left over. In this case, x squared minus 2. And this is the factored form of that expression. All right, now sometimes we may come across what are called special polynomial forms. And so we're going to look at some examples of these special polynomial forms. The first is what we call a difference of 2 squares. And so first thing we need to do is identify that we have a difference of 2 squares. So we know that the word difference means subtract. And so this should be the subtraction of 2 perfect squares. So something like u squared minus v squared. Now the result of factoring that is 2 parentheses and we take one of the u's and one of the v's and place them in each. One parentheses gets a plus, and the other parentheses gets a minus. So for example, if I look at the letter A, I know that 100 is 10 squared, or 10 times 10. 4y squared is 2y times 2y. It's a difference. So when I factor, I should have my two sets of parentheses with a 10 and a 10. I place a 2y in each as well. One gets a plus and one gets a minus. This is the factored form of 100 minus 4y squared. We have a similar idea in B. We have a perfect square here, which is x minus 1 times x minus 1, and 3y squared times 3y squared. So when I factor, I get two sets of parentheses. I'm going to take an x minus 1 and place it in each. Let me rewrite this for you. Two sets of parentheses. We have an x minus 1 in each. We have a 3y squared in each. One gets a plus, one gets a minus. Okay, and another similar idea in C. We have 81x to the fourth, which is 9x squared times 9x squared, and 16, which is 4 times 4. So when we factor, we get 9x squared plus 4 and 9x squared minus 4. Now the trick on this one is this second term, the 9x squared minus 4, is also a difference of squares. 9x squared is 3x times 3x, and 4 is 2 times 2. So because it's a difference, a subtraction of two squares, then I can continue factoring. We take 3x in each, a 2 in each, one adds and one subtracts. And this would be your final answer here, the complete factorization. Now the second of our special cases is what we call a perfect square trinomial. So in a perfect square trinomial, we have a perfect square at the beginning. The center term is the product of the two factors times 2. And then the last is also a perfect square. And when we factor this, we get one parentheses that's squared with the first term and the last term. All right, so this first example, first let's check and see if it's a perfect square. So a perfect square trinomial, excuse me. It's got 3 pieces, and I have x times x, 7 times 7. So we've got the outside parts taken care of. Now we just need to check the middle. So if I were to multiply x times 7 and x times 7 again, this combination does give me 14. So I know it's a perfect square trinomial. And when I factor it, I'm going to take 1 from here and 1 from here, as well as this first sign. Okay, and that's my answer there. In part B, similar idea. I have 3x times 3x, and I have 5 times 5. If I were to multiply, I would have 15x and another 15x, which is, of course, 30. So I know my answer is going to be a perfect square. One from the beginning and one from the end. And whatever this first sign is. And this is your answer here. Okay? Now, the next of our special cases is what we call a sum or difference of cubes. So in this case, well, we have our cubes. So something like u to the third plus v to the third. And when I factor that, I get u plus v times u squared minus uv plus v squared. Now if we were to have the difference, we would take u to the third minus v to the third and factor that as u minus v times u squared plus uv plus v squared. So essentially what's happening is you have to have two cubes. So in A, 64x to the third is 4x times 4x times 4x. 1 is, of course, 1 times 1 times 1. So this is a difference, so we're looking at this second case here. I end up with two parentheses, one that's a little longer than the other, and I'm going to take one of the first things and one of the last things, and I'm going to keep the initial sign, which is the minus. I'm going to take the 2 that are left over from the first, the 2 that are left over from the last, and I'm also going to multiply 4x times 1, 4x. The sign here should be opposite of whatever it is that I see in the first parentheses, and my second sign is always a positive. Okay? Now when I look at B, I notice that I have a 5 in common for each of these. So I'm going to take that 5 out. And when I do that, I end up with 5 times y to the third plus 27. Y to the third, of course, is y times y times y. And 27 is 3 times 3 times 3. So we're going to keep our 5 in the front, and we're going to set up our two parentheses. I'm going to take 1 and 1 with the first sign, which is the plus right here. I'm going to take 2 and 2. I'm going to multiply. Y times 3 is 3y. I'm going to use the opposite sign. And then always plus. Okay, and a lot of this takes some practice. You just have to get used to practicing it. Okay. Then the next thing we have is just factoring trinomials with a leading coefficient of 1. So that means that the number here in front of the x squared, is a 1. So the method that I use involves setting up two parentheses, separating the x into each parentheses. I bring down my first sign, and then multiply. A positive times a negative is a negative. I look for things that multiply to give me 6. But that either add or subtract to give me the 1 in the middle. So in this case, 3 times 2 is 3 times 2 is 6, but 3 minus 2 is 1. So I place the larger number in the first parentheses and the smaller in the second. And this is the factored form of x squared plus x minus 6. Same idea with B. Set up my two parentheses, x and x. I bring down my first sign. Positive times positive is also positive. I take the number 40 and I find things that multiply to give me 40. And I look for a pair that adds or subtracts to give me 13. So I see that 8 and 5 is 13. I place the larger number in the first parentheses and the smaller in the second. And this is the factored form of x squared plus 13x plus 40. Same idea with C, two sets of parentheses, x and x, bring down the first sign. Positive times positive is positive. We look for factors of 8 that are going to add or subtract to 6. So of course 4 and 2, bigger number, smaller number. All right, and the same on the last. We have x and x. Bring down the first sign. Negative times negative is positive. I'm going to find numbers that multiply to give me 14, but either add or subtract to 5. And of course 2 and 7 gives me 5 by subtracting. Bigger number in the first parentheses, smaller number in the second. And this is your answer here. I know that some of you know the box method. If you feel comfortable using the box method, then by all means, please do. Okay? This is just the method that I was taught and that I prefer to use. Okay, and we can do the same thing with a trinomial whose leading coefficient is not 1. So now in this case, how we set it up a little bit differently is we set up two sets of parentheses, And we take this first number and we're going to place it in each along with that x from the front. I bring down my first sign. A negative times a positive is a negative. I take the product of the two outside numbers, which is 6, and I find the numbers that multiply to 6. So now I need a pair that in this case adds to 5 because I have the same sign, negative and negative inside my parentheses. So because of the same sign, I need to add to 5. So we put the bigger number in the first parentheses and the smaller in the second. Now, I made my parentheses a little bit bigger by putting an extra 2 in. So I'm going to take each of these and divide by their greatest common factor. So the biggest number that divides 2 and 3 is 1. The biggest number that divides 2 and 2 is 2. So from here, I have 2x minus 3 and x minus 1. And this would be our factored form here. Okay. And we have a similar idea with b. If I take my two parentheses and I place a 12x in each, I bring down my first sign, which is positive. Multiplying a positive with a positive also gives me back positive. I multiply my two outside numbers. 12 times 1 is 12. And I'm looking for things that multiply to 12, but either add or subtract to 7. So 4 and 3 is 7. We put the larger number in the first parentheses and the smaller in the second. Now I made everything a little bit bigger by putting two 12s in here. So I'm going to take each of these and divide by their greatest common factor. So the biggest number that divides 4 and 12 is 4. The biggest number that divides 12 and 3 is 3. This leaves me with 3x plus 1 and 4x plus 1. And this is the factored form of that expression. All right, and we've got one more of these here. I set up my two parentheses, 2x and 2x. I bring down the first sign. A positive times a negative is a negative. And we multiply the two outside numbers. 2 times 3 is 6. So now we know that 6 is 1 times 6 and 2 times 3. I need a pair to give 7. And so 6 and 1 is 7. Larger number in the first, smaller in the second. The biggest number that will divide 2 and 6 is 2. The biggest number that divides 2 and 1 is 1. So that leaves me with 2 minus 3 and 2x minus 1. And this is the factored form. Okay. Now the next thing we have is factoring by grouping, which we usually use when we have more than 3 terms or 3 pieces. So usually like 4. And in this case, all of the terms don't have a common factor, but if I put them into smaller groups, they have something in common. So for example, if I take A, my first two values, I see that they both have an x squared in common. When I take out the x squared from this first term or first group of terms, I have x plus 4. My second group of terms, these two here, both have a 3 in common. So when I take out the 3, that leaves me with an x plus 4. The x plus 4 here becomes now the greatest common factor of the whole thing, and I'm left with x squared plus 3. And this is the factored result of that expression. Now b works in a similar manner. I just have to pay attention to my signs. So these first two, x to the third plus x squared, have x squared in common, which leaves me with x plus 1. Now when I get to the second two, I notice that they have opposite signs. So in order to get this same parentheses, I'm going to need to take out a negative number. So I'm going to take out a negative 5, which leaves me with x squared plus 1. Because negative 5 times x would give me back the negative 5x I was looking for, and negative 5 times 1 gives me back the negative 5. Now my two parentheses are exactly the same, so they become the greatest common factor, and I'm left with x squared minus 5. And this is the factored form. So in terms of strategies for factoring a polynomial, we always want to check if there's a common factor first, and if we find one, we take it out. Then I want to see the number of terms and see if there's anything special I can do. So I check the number of terms. Is it a difference of 2 squares, a sum of 2 cubes, or a difference of 2 cubes? If it is, then I use those formulas. If not, is it a perfect square trinomial? If it's not a perfect square, then I would try factoring just like we did before. If I have 4 or more terms, we use grouping. We check to see if we can factor any more, and then we're completely done. So if we look at these examples, when I look at A, I can see that each of these terms has a 2 in common as well as an x. So when I remove 2x, I'm left with x squared plus 4x plus 4. Now this looks to be a perfect square trinomial. In order to check, I check x times x and 2 times 2. When I put them together in the middle, it definitely generates the 4x, so we're good. Because it's a perfect square trinomial, I know that I'm going to take one term from here and one from here, as well as the plus sign. And this would be the factored form of that expression. Looking at B, I can see that all of these numbers are divisible by 3, and they all also have an x. So if I remove 3x, I have x squared minus 10x plus 25. Again, this one also might be a perfect square trinomial. So let's check. X times x and 5 times 5. 5x with 5x definitely gives me 10x. Another perfect square. I take 1 and 1, and my sign comes down. All right, we're going to skip C because I don't know what I did there. I made a mistake on that question. All right, and we'll go to D. All right, and we made a mistake on this one too, so we're going to have to look at these together in class. But at least this gets you started, and you can practice the beginning part of Section P4. If you have any questions, make sure you come and see me before or after school.